Welcome back, ladies and gentlemen. Today we're going to talk about section 12.5, the area of pyramids. Up on the screen, as usual, you'll see your exit question for the day. To start today, I am simply going to give you a fact that you can assume to be true. If you would like to see a proof or at least a demonstration of the fact that this is true, there are several YouTube videos that talk about it. You might even be able to find a very rigorous proof using some pretty high-level mathematics to prove this point. But what this fact is basically it totally relies on the work that we did in the previous section to find the volume of a prism to figure out the volume of a pyramid. And it basically says, well, that if you have identical bases and identical heights, that the volume of the corresponding pyramid will be 1/3 of the volume of the prism with that same base and same height. So if you know the volume of a prism, to find the area of, in this case, a pentagonal pyramid with the same height and same base, you simply divide by 3. And likewise, if you have a pyramid already, or in this case a special type of pyramid called a cone, and you want the cylinder to go along with that, or the volume of the cylinder, so find the volume of the cone and then multiply by 3 to get the volume of the cylinder. And here they are stated as theorems in your book. There are 2 of them, though it really only needs to be 1. 12.9 is the big one. It covers all pyramids, including cones, and then 12.10 specifically calls out cones in its own special case. But you can see it's based on what we did last section, where it's basically the same volume formula, except it has a factor of 1/3 written in it. So it's 1/3 times the area of the base times the height of, in this case, the pyramid instead of the prism. And like always, remember that I'm going to use a big H to represent the height of the overall solid, and I'm going to use little h if there's a height of a triangle or a trapezoid within the solid. Down below in 12.10, you can see that it is the same theorem, or the same formula is stated again, but it's made more specific for a cone, which has a base of a circle, so you have pi r squared as the area of the base, and again that little h pops up where I'm going to use a big H. So the toughest part of this section is being able to take these volume formulas and being able to write a generic formula for the purposes that you need. This formula has to cover all pyramids with some sort of polygonal base to it. So it can handle a square base, a triangle base, a octagonal base, etc. So what I'd like you to do right now is I'd like you to pause the video and I'd like you to try to write a volume formula for each of these 2 solids using the labels that are given in each drawing. If you do that correctly, they both have a factor of 1/3, and then you get into the area of the base. So the area of the base on this one is a triangle, so you have 1/2 base times height. There's that little h versus the big H coming into play here, times the height of the overall pyramid. So it looks like that. Down below, the hexagonal pyramid is a little bit more difficult. You still have that 1/3 factor. The area of the base uses that 1/2 times the apothem times the perimeter times the height of the pyramid itself. And then, of course, the perimeter is going to be 6 times the value of b because there are 6 sides to it. If you can handle writing these 2 formulas yourself without any assistance, you're going to do pretty well here, because from this point onward, all you have to do is plug in values. Let's do an example. The example here I have is something called a composite solid. That means it's made up of 2 different shapes. And what this picture is, I just want to clarify the picture, it is a cylinder with a carved out middle in the shape of an octagonal, a regular octagonal pyramid. There are only 2 numbers given, and through those 2 numbers we're going to be able to calculate the volume of this shape. So we have a radius given and a height of the overall shape, and the pyramid goes all the way down to the bottom of the cylinder. So to start off with, I'd like you to think about a strategy on how to find the total volume of that composite solid. Now there are probably many ways to do that, but the way I thought to do it would be to take the volume of the cylinder and then subtract the volume of the pyramid that has been carved out of it. So the volume of the composite shape is going to be the volume of the cylinder minus the volume of the pyramid. From there, we can use our volume formulas, one from yesterday because that's a special type of prism, and one from today that's going to have an additional factor of 1/3. So see if you can write a generic formula based on this information, one term being the volume of a cylinder and one term being the volume of a pyramid. If you do that well, you got pi r squared is the area of the base of the cylinder times how tall the cylinder is. And for the pyramid, you've got that factor of 1/3, and then the base of the pyramid is an octagon, so you've got 1/2 apothem times the perimeter, and then times how tall the pyramid is. So according to our drawing, we have our height, so big H is 3, and we have a radius, which is 2. So that term's covered. And over here, we need an apothem as usual. They're almost never given to you, and then times a perimeter, which is the perimeter of the octagon, which is also not given. The height is there, it's still 3, whether it's the pyramid or the cylinder. So let's draw the base of that octagonal pyramid, and this is the information given. As usual, we need the apothem, so we're going to draw a perpendicular segment right here and label the apothem, and we might as well label the far side because that'll help us determine the length of one of the sides of the octagon. From there, we need at least one more piece of information to figure out the length of A and the length of B. And because this is a regular octagon, we can figure out that angle by taking 360, divide by 8, and then divide by 2, and that'll give you a degree measurement of 22.5 degrees. From there, it's writing trig ratios to figure out B and figure out A. Why don't you pause the video and see if you can write those trig ratios and find those values. When you do that correctly, the equations look like that. To solve those equations, multiply both sides by 2, and you get those values right there. And then we can start plugging it into our formula up here. So we have pi, the radius is 2, the height is 3. We have 1/3 times a half, so 1 times 1 is 1, and 3 times 2 is 6. So we can replace that term as a 1/6. The apothem is 1.848. The perimeter is going to be 16 times the value of B, and height will be 3. So you plug in all those numbers, looks a little something like that. Your calculator can do the work from there, and we are asked to round to the nearest hundredth. So it's 26.39, and then we throw a label on there, cubic yards, because we're dealing in volume. There's your assignment for tomorrow. I'll see you next time.